Well, good afternoon, guys, and welcome to this edition of Kayleigh's Weather Workshop. So last week, if you joined us or if you caught our web article afterwards, we talked about what a weather front was, and we talked about how that was a boundary separating two very different types of air masses that had lots of different qualities, including temperature and density. And today, we're going to dive deeper and kind of expand on expand on what we learned last week about how warmer air was less dense, and we're going to do a better illustration of that. So what you will need for this experiment, you're going to need two bowls. I just have two empty cereal bowls. These are the ones I eat cereal out of every morning, just anything you have laying around your house. You're going to need some cold water. I know you can't tell the temperature, but this is cold water, some warm water. It doesn't have to be boiling, but just warmer, and definitely parents, help your kiddos out with that. We don't want anyone getting any sort of burnt fingers. And then I also have a cup of ice here, and just any ice. It's just a little bit of ice there. And then two empty water bottles without their caps. And lastly, two balloons. So first, we're going to take our balloons. Any color will work, but I'm just going to demonstrate. This is going to be our balloon that we put in our cold water, and this is going to be the balloon that we put in our warm water. So let's see if I can do, this is the part I struggle with. So parents, help the kiddos out, or maybe kiddos have to help the parents. Just stretch the balloon over the opening of our water bottle there, just like that. So it's attached, and you can kind of try and center the balloon on top of your water bottle. There's one, there's our first one. And you'll just do that one with our other balloon. Stretch it out, put it over the top of the water bottle, and make sure you don't have any gaps. You don't want any of that air to escape. Completely surrounded underneath that lip of the water bottle is probably the best place for it. So we have two balloons on top of two water bottles. We're going to set those off to the side. So next, you're going to take your two bowls. First, I have to feel and make sure which one is my hot water. We're going to take our cold water first and pour just a little bit of that into your bowl. Not too much, because we are going to be submerging this in there, so you'll get some of that displacement there. And also put a few ice cubes in there just to help it out a little bit. Smaller ice cubes would probably be better. Ours are a little bit big. Smaller would probably help you out a little bit. And then take your warm water and carefully, ours is steaming right now, very carefully pour it into the other bowl. All right, now's the fun part. I bet to all of you that I can inflate this balloon without putting any extra air in this water bottle. And it's a pretty good bet, because I know that it's going to work. So you're going to set the bottom of your water bottle into the warm water and just watch what happens. I promise I'm not squeezing anything. That did it all by itself. I'll switch my hands. We can see that that balloon is now inflated more than it was when we first did it. So now, I'm just going to set that over to the side, and it'll keep that there for a little bit. See, still inflated. I'm not touching it. Nothing's being squeezed. It is still inflated. Now, this balloon. This one may be just a little bit more difficult to see at first, but we're going to let it sit there for a little bit. So this is your other water bottle. This is our cold water. We're going to stick it in there, and we're just going to let it kind of sit. And you kind of have to look back at the back part of your balloon. You can start to see it kind of suck into itself. The air that was in the balloon is now being sucked all the way down into your water bottle. So why does the balloon, we're going to let this one sit, but why did our warm water balloon inflate by itself? Well, that's because of the air density. Now, density is it's an equation, and it's mass over volume. Now, putting the balloon, now it's starting to deflate because the air is starting to cool down, so let's put it back in there. So with the balloon on the top, we've created a closed system. So we have a fixed amount of air in our water bottles. So the only thing that we can change is the volume of air, and that's how we're doing that through temperature. So I'm going to put this one off to the side now. So the warm water in this bowl is the water is warming the air that's already inside of the bottle. This makes the air, the molecules rather of air start to move a little bit faster and start to spread out. Now this last week we saw in the form of the oil on top of our water, it was lighter, it was less dense and warmer, so it was going above that denser cool air. And we can see that here with that warm air rising. Now we can really see a difference if we go from this warm water, and we can even see a little bit of condensation going on here on our bottle. We're gonna go from the warm water to the cold water and we'll see a bigger change. Really watch this balloon because it'll start to soak in, or suck into itself rather, because that air is becoming more dense. We're starting to get that volume closer down to the bottom. Okay, so here we go. Into the cold water we go. Slowly, it's happening. We may have to cool the water down a little bit. I think we're gonna have to cool the water down a little bit. Held it in the warm water. There it goes. There it goes. So slowly, I'm gonna turn it so you can see the balloon start to deflate. Slowly but surely, all of the air that is in this balloon is starting to cool down. The molecules aren't moving as quickly, so they can start to settle closer together. There it goes. It's starting to suck into itself there. I'm gonna put a little bit more ice maybe. See if it'll keep going. There we go. Cool it down. And honestly, if you move the bottle around a little bit, that'll start to agitate the molecules of air in there and start to cool it down a little bit more. So that's pretty cool, right? So again, this is just demonstrating what we saw last week with that dyed blue, just normal water. That is, as those air molecules start to cool down, they're becoming more dense, a little bit heavier, and sinking to the bottom and leaving our balloon over here. So what does this have to do with weather? So when we're entering into spring, right? So when we enter into spring, we're talking about thunderstorms, rainstorms. So what does this have to do with any of that? So this warm air, this can illustrate warm, humid air starts to rise up, just like this. Slowly but surely, it goes up and fills up the balloon. And when it starts to warm up and it hits a point in the atmosphere and it starts to condense, and you can honestly see that if we zoom in here on the bottle, you can see a little bit of condensation happening, a little bit of the water cycle. So as the warm air reaches that point in the bottle, that's the point in the atmosphere, it's gonna start to cool down and condense. And we can see some of those drops getting a little bit on the larger side there, and that's when that cloud is getting too filled with liquid, too filled with moisture, and it has to rain out. So this is what's creating those pop-up rain showers that we see so often during the springtime and even into the summer. So that's pretty much our experiment, except I do want to do this. I mentioned that an optional part of this experiment was a pitcher or a deeper container. So what we're gonna do is fill this with that cold water. I'm not gonna pour it from the bowl because I'm just gonna make a mess. So your deeper container, this will just allow us to submerge our warm air bottle to really see what that cold air does to it. So let's pour into our deeper container. You can fit a little bit more ice in there too, so you can, again, cool the water down a little bit more. There we go. All right, actually I am gonna pour some of this in there and we're just gonna be really careful. Parents, this is where you come in handy. There we go. All right, so now, hopefully we'll be able to see, so we can see it's the air inside this bottle is actually starting to cool down a little bit. So it's increasing in density. And that's why we're starting to see that balloon start to deflate a little bit. So let's put it in our bigger pitcher and let it sit there for a minute and see. Because this way we can surround the bottle a little bit more. And now the balloon is already deflated quite a bit. And we're even starting to see it kind of go into the bottle. I'm gonna let it sit here for just a little bit longer. Again, the cooler air condensing, getting very, very cold, and there it goes. We're seeing the air suck the balloon into the bottle itself. Well, guys, that was this week's Kayleigh's Weather Workshop. I'll see you back here, not next week, but the next week for a new experiment. Contact me online if you have any sort of experiment that you would like to see worked out here on Kayleigh's Weather Workshop. See you guys next time.